Hi, my name is Jim Grachowski. I'm an instructor in the health branch at the Osha Training Institute. My goal in this video presentation is to describe the operation and use of two types of velometers which are used to measure airflow. These devices are used to determine the effectiveness of industrial ventilation systems, such as a laboratory hood or a spray paint booth, to mention only a couple of examples. The equipment used in this video has been selected to familiarize the viewer with how to take air velocity measurements. Use of these specific devices does not constitute endorsement by OSHA. There's a wide variety of similar devices available on the open market. The first type of velometer I'm going to describe is the Alnor thermal anemometer model 9850. More commonly referred to as the pocket hot wire velometer. It is a battery-operated, direct reading device capable of measuring air velocities of 20 to 2,000 feet per minute in two ranges. It has a retractable 3-inch probe used to measure the airflow. The owner's manual should be read before use. I'll be summarizing information found in the manual. The Alnor model 9850 uses two wires to measure air movement. One wire senses the ambient temperature of the airstream, and the other wire is heated above an ambient temperature by an electrical circuit. As air passes over the heated wire, produces a cooling effect proportional to the airflow, and a change in voltage across the wire is created. It should be noted that the use of this device in heavily contaminated environments may affect the electrical voltage and thereby affect its accuracy. If such a condition is suspected or if damage to the wires occurs, the device should be sent to the Cincinnati Maintenance and Calibration Laboratory for repair. The accuracy of this device is stated on page 10 of the owner's manual, along with other specification information. The accuracy is plus or minus 3% of the reading and plus or minus 1% of full scale. Now see the UL listing on the cover of the device and also on the instruction manual. Note that the unit is intrinsically safe, but only in certain locations as specified. This is critical to safe operation and must be considered before using the velometer in any environment to prevent creating a hazard. To prepare the velometer for use, first check the 9-volt battery. You do this by sliding the switch at the top of the device to the battery position. Note the position of the needle on the instrument face on the right-hand side. If it is in the dark battery zone on the right-hand side of the meter, it has sufficient energy for use. After checking the condition of the battery, check to make sure that the device is mechanically zeroed. You do this by turning the unit off, and if necessary, using a screwdriver to adjust the needle on the face of the instrument so it reads 0. Make sure the calibration of the device is within date. The Maintenance and Calibration Lab in Cincinnati, Ohio calibrates this velometer every 2 years. The electrical zero adjustments or low and high span adjustments are only used for calibration purposes by the Cincinnati lab. Now once the battery has been checked and the zero has been checked, the device is ready for use. These steps taken to prepare the device for use should be documented on the OSHA 93 form. Measurements should also be documented on this form. Screening information should be reported to the IMIS system by using the OSHA 98 form. Now, the second type of device I'm going to describe today is the Alnor Series 6000P velometer with the low flow probe attached. This velometer comes in a kit with many attachments. I'm only going to discuss the low flow probe today. For information on the use of this probe and other attachments, see the manufacturer's operating instruction book or attend the Principles of Industrial Ventilation Training class at the Osha Training Institute. This device is not battery operated and does not present an electrical hazard in hazardous environments. Airflow measurements are displayed on this direct reading device when velocity pressure is exerted on a swinging vane located in the device. The velometer is capable of measuring 30 to 300 feet per minute with the low flow probe attached. The accuracy of the device is plus or minus 2%. Now the probe fits directly over two fittings in the back of the velometer. It can only be attached one way, with the arrow on the probe pointing to the left when looking at the front of the device. If the device is used in heavily contaminated environments, the accuracy of the device may be affected. The velometer is also calibrated by the Cincinnati lab every 2 years. Now before use, check the zero adjustment. This is done by closing both ports on the low flow probe to prevent any air movement into the device. While holding the device in a normal upright position, the needle should indicate zero on the face of the dial. Turn the screw adjust located at the base of the device slowly until the needle indicates zero. The device is now ready for use. Both of these velometers are designed to take measurements of the air velocity by pointing either probe arrow in the direction of air flow. The opening of either probe should be parallel with the air flow. If the direction of the airflow is uncertain, either probe should be rotated to obtain the highest reading. The highest reading would indicate proper positioning of the probe in the airflow stream. While measurements are taken, the needle on either device will fluctuate. After observing the fluctuation, a range of movement should be noted. An average of the range of the movement should be recorded for the reading. For example, if the range is 100 to 200 feet per minute, 150 feet per minute would be recorded on the Osha 93 form. Now remember, while taking measurements, avoid placing your body or other obstructions near the area being measured. Such obstacles will affect the movement of the airflow being measured. When taking measurements for the average face velocity at a spray booth, for example, an average velocity can be determined by dividing the face area of the booth into sections of equal area and measuring the airflow at the center point of each section. After recording velocity measurements at each point, add up all the measurements and divide the sum by the number of points or sections used. In conclusion, these instruments provide airflow measurement information for evaluation of the condition of industrial ventilation systems. This is only one factor which must be considered when determining compliance with OSHA's ventilation requirements and other safety and health standards.